notes for completing the reaction. You'll want out a periodic table and your formula page. Let me show you what I mean by that. It looks like this. Here's the top part of it. This will be in your Schoology folder, and this is the back side. We will primarily be using these three pieces for this. This activity series and the common gas grid. Okay, so hopefully you've gathered those things either virtually, electronically, or hard copy. So, you're going to have to still maintain your skills of writing chemical formulas to be able to complete the reaction. So, I am going to look at this thing here, and I'm going to write an equation for it. So you got to think about the fact that this is Mg2 plus and Br1 minus, and then this is chlorine. Okay. If there are two words to the chemical formula, you're going to use one of your rules, either crisscross reduce, prefixes or name as an acid. If it's one word, you got to think about whether it's Brinkelhoff, yes or no, diatomic, yes or no. So at Brinkelhoff, there are 7 of them. And if you remember from first year, hopefully you were taught this. If not, you're going to learn this now. These are the 7 diatomics. It spells the word Brinkelhoff: bromine, iodine, nickel, chlorine, hydrogen, oxygen, fluorine. They spell the word Brinkelhoff. They are diatomics when they're all by themselves. That means alone, single word. Here, bromide comes from bromine, but it's with a partner, so it cannot be a diatomic. They're only diatomics when they're all by themselves. That should be a review from first year chemistry. So 2 words, so I'm either going to do crisscross reduce, so the ionic method of naming compounds, or I'm going to do prefixes, the covalent method, or acids. Okay, you're mostly going to have ionics every once in a while, a covalent, and acid's probably the second most popular after ionic. So we're going to do crisscross reduce, so it's going to be MgBr2. If you are still struggling with this skill, you need to get into a Google Meet or get in after school, before school, and get extra help. Okay, so magnesium, bromide, and chlorine. Okay, so on that formula page, you had this piece of this grid, or table, pardon me, and this table and one more. If you're always going to start and see if it's here every time start here. You will have this at your disposal on a test or a quiz. So is it one of these things? Is it one of these things? So what do we notice? We have a compound and an element, so it would have to be one of these because there's only compounds here. So what I'm looking for is, do I see then a CO2, H2, or O2? I do not. So it is not what I call a decomp or a synthesis. I call these a special quotation marks decomp and a special synthesis. That's just my phrasing for it, just because they're not just ordinary elements breaking down or elements coming together. Okay, so now that we know that this is not a case, if it's an element and a compound, whether we say compound element or element compound, we will look to the activity series to see if it actually makes a reaction. So I'm going to find the person that's alone, chlorine. Okay, chlorine is right here. Okay, and it forms negatives. Or I shouldn't put in 1 there, I guess, just negatives. And this group, except for this group's going to form hydrogens. Okay, so chlorine is negative, so I'm going to see who chlorine would replace. It's going to have to replace someone in its list. Negatives can only replace negatives, positives can only replace positives. So chlorine is going to try to replace either fluorine, bromine, or iodine. So chlorine's going to try to replace bromine. Negatives replace negatives, or you could say nonmetals replace nonmetals, or metals replace metals, or positives replace positives. This is a negative replacing a negative, only option I have, because it only can replace within its same column. So then I will go over here and I'll say Mg and Cl. I'm going to bring the atoms over, and then Br. Now I'm thinking about Mg and Cl. It's a new relationship, so I have to regroup and rethink about how they go together. What does this relationship look like? So this is 2 plus and 1 minus, so I'm going to crisscross reduce. It's going to go like that. This is all alone, so when it's all alone, I have to think about Brinkelhoff, yes or no. It's a yes, and now you're going to balance it. I am not going to take the time in this video to balance. I'm going to expect that you can go ahead and balance. There is an answer key for you to check your balancing at the end. Okay, we got silver nitrate and zinc chloride. So we're going to start by coming up with the formulas. This is a +1, this is a -1. If you don't know how to find these, or if this is still a struggle, as I said before, please reach out. So Ag goes with NO3, if I crisscross reduced, and zinc is like that. Bring the 2, bring the 1. Now, always start here. It is not either of these. So then it could be a common gas. Could be. Okay? So notice when it's 2 compounds, you're going to go to common gas. Kind of flows. Compound, common gas. If we go back here for a moment, this was an element in the compound, so I have to do the activity series. So element, compound, everybody starts here every time. Element. And if it's an element of compound, you would look here. What do I mean by that? The first part of the reaction, the reactant side of the reaction has an element of compound, you would go here. On this one, remember, you're always going to start here. 2 compounds, so I have to check to see whether it's a common gas. Now, this is very misleading. These are really not useful to this chart for the purposes we're using. Really, I would ignore this, because what you're looking for, if it's a common gas, it's going to have one of these. And we'll go over all these examples of common gas through these notes. Okay, so it's going to have one of these 3 endings, okay, as the anion or this cation. And I don't see any of these here. So it's not a common gas either. So that means it's just a plain old single replacement. I'm going to anchor the fronts, meaning put the positives in the same order, and switch the backs. Remember, I'm only bringing over the ions. The ions that formed this was Ag plus 1 and NO3 1 minus, zinc plus 2, and Cl 1 minus. If you think about it, what I mean by that, you would have to have realized that these are the 2 ions that make this up. And this should be something that you can do with a little bit of practice because you've already learned this skill of this piece. Okay, so then I know that this was a plus 1 and a minus 1. Now, for the purposes of this video, we're going to say that the plus charge does not change. So that is not the case in all of chemistry, but for our purposes, to ease into things, we're going to say that the charge does not change, meaning if it's a plus on this side, whatever plus value it's on this side, we're going to carry it over. Okay, so crisscross reduce. Oop. That is not how that goes. I apologize. It would be 1 to 1, so it would not be a 2 there. Okay, now this is what I was thinking ahead here. This is a plus 2 and a minus 1. I'm going to need parentheses around. Remember, I got to protect my polys, and then I'm going to balance. Again, I am not balancing for the purpose of this video. You can do that on your own and check your answers. You are expected to balance, but I will not in this video. Okay, next one. I have Mg. A word by itself. It's not a diatomic. Remember Brinkelhoff. So it's not any of these: bromine, iodine, nickel, chlorine, hydrogen, oxygen, or fluorine. Chlorine is a Brinkelhoff. Now the only thing this could be is 2 things coming together. So it can only be a synthesis. Yes, it can only be a synthesis, 2 things coming together. Okay. So I just have to assume they go together, and it's not any of these special syntheses because I don't have CO2, H2, or O2. So it's just Mg going with Cl. Again, remember, the new relationship is always what are the ions that form from the pieces on the other side. We know this is a plus 2 and a minus 1. I'm going to crisscross reduce, and it's going to be this. When you write these, you need to either scratch out or write it high enough that it doesn't look like it's part of your balanced equation. Okay? And then you're going to balance. Okay, on this one, we're going to check this box. Remember, I've always said we check this every time. Notice it's this one right here. Because there's an X. Remember, X is a metal. Okay, and I don't know if I've said that yet, but X is a metal, any metal. So X represents any metal. That's what the X represents in all of these. So then it's going to go X with O. So what's my X? My X is Au with O, because that's what the metal is, and then CO2. That's what this tells us it forms. Okay, CO2 we know is good, but we have to think about this new relationship. How does it go together? Now, in order to get this charge, because when you look on your ion sheet, you're going to see that gold can be multiple oxidation states, meaning multiple plus values. So we have to refer back to what it was here. So we're going to say this was really this. If you think about it, when we wrote this, we would have gotten rid of the 1 right in the parentheses, right? So we're going to reverse crisscross. We've been practicing this. That's what you did last week. Okay, we're going to check the negative. Should CO3 be a minus 2? Yes. So that means this, in fact, is gold 1. So then I know this is a plus 1 and a minus 2. Remember, write your charges high so it doesn't look like it's part of it, or cross them off. And those are too close, so I'll be crossing those off in a moment. Crisscross reduce, so the 2 is going to go here. Okay, now I'm going to erase those so I don't, or cross through them so it doesn't look like it's part of the thing. And then I'm going to balance. This was already okay because I knew it was CO2 because it told me. All right, this is a combustion. How do I know it's a combustion? It's a hydrocarbon plus an oxygen. So a hydrocarbon plus an oxygen is always going to form, for the purposes of what we're doing in this part of the unit, H2O, CO2 and H2O, CO2 and then H2O. Now you need to balance it. All right, here we go. So this one, we have two compounds. We're going to start here. It is not any of these because I don't have those. It couldn't be this because there's only one thing before there. Oh, this has two. So it's none of these. Remember, this is useless to us, but anytime it's two compounds, I got to check to see whether it's a common gas or just an ordinary double replacement. So what am I looking for? Remember, we're looking for an S2 minus, an S2 minus ending, an S ending, and CO3 ending, an SO3 ending, or an NH4 start. Okay, this has an NH4 start. So there's a yes to this part. But it also has to have a strong hydroxide. Remember, hydroxide is OH minus 1. For the purposes of this course, I will only give you the scenario where if you have a hydroxide, it's a strong. So don't be worrying about if it's strong or not. So this is a yes and a yes. So then it tells us what it forms. It tells us it forms NH3, because it says, and any ammonium salt, that this is an ammonium salt, plus a hydroxide, strong hydroxide, that's a strong hydroxide, reacts upon heating to form NH3, HOH, plus a salt. So the salt is the unknown, right? And it's going to be the front that we haven't used Na yet, and a back that we haven't used. So a positive we haven't used and a negative we haven't used. So NaASO3. I know that this is a +1. I looked this up and see this is a -3. Remember that it really doesn't matter if you do +1 or minus or 1+. I have a habit of going back and forth. I don't care which way you do it. Unless directions tell you I need it a certain way, I don't care which way you do it. So there's going to be a 3 here. The 3 comes down, the 1 goes down and goes away, no parentheses. Please balance. Okay, next one. This is going to be an element in a compound, so I'm either checking my box like we always start here, or remember, element compounds, I go to the activity series chart. The higher they are here, the more reactive they are. Okay, so I'm looking here and I see that in fact it's this one right here, because I have something with chlorine plus an oxygen. So we're going to know it's going to make that same metal, the same X value. In this case, X is here, right? And then ClO3. Now I got to know how this goes together. I know this is a -1, but this is a plus what? Well, manganese, Mn, has many plus charges. So I'm going to have to go to the other side to figure out what the plus charge is. Split it, reverse crisscross. We know there's a 1 here, even though we don't write it. Should Cl be a -2? It is a -2. Apologize. Should Cl be a -1? Yes, it's a -1. So this is a +6. Now I'm going to crisscross and bring my 6 down and bring my 1 down. And now your job is to balance it. Okay. That one we were going to skip. Feel free to practice if you would like. You can always check it on the key. Number 9. Okay, so this is a magnesium chloride. Now, how do I know it's that? Because I would have thought about the charges. Bromine, a word by itself, so yes, it's part of Brinkelhoff. Okay, one more time. Those are my 7 diatomics, my 7 Brinkelhoffs. All right, so it's a compound and element, so I got to look here. It's none of these. Yes, there's something with a chlorine, but that's not an oxygen, so it's not any of these. And I got it. So now I'm going to see who's alone. Bromine's alone. Bromine's trying to kick out someone in the relationship, right? Or someone in the dance group, right? These guys are dancing. This person wants to dance. That's my little trick I always tell my kids. So bromine is going to try to kick out chlorine. Bromine is lower, so it can't kick out chlorine, so there's no reaction. It has to be higher, more powerful, more reactive, really, to kick it out. So the phrase really is more reactive, but we want to say higher or more powerful to kick it out. Bromine can't because it is lower. And I think I mentioned this on this problem, but I'm nervous I didn't, so I'm going to go back and talk about this here just a moment. Back to number 1. I believe I mentioned that we were looking, chlorine was all alone, so here's chlorine, and chlorine is more reactive or higher, so in fact did replace bromine. If it's higher, it can kick it out. If it's lower, it cannot. Remember, this one, bromine is lower, so it cannot kick out chlorine. It can't replace it. It just stands there looking sad. All right. Some of these we're skipping because they're ones we've already gone over. Okay, so we have two compounds. Got to check here. It's not any of these. So now I have to see, this is the wrong chart. Let me pause and fix that. Give me just a moment. Okay, that's the correct two charts. Always have this one as a guide, right? And then if it's two compounds, I got to check whether is it a common gas or is it just a double replacement. I see, let me get my pen working again. Sorry about that. I see that it ends in S2 minus. One of the two do. It doesn't matter which one. It could be first or second. So, and then it says plus an acid. So that has to be two. All of these are two-check system. Yes, that's true. Is there an acid? Of course. Remember, hydrogens in the front, we're going to claim are acids. Okay, so then it tells us it forms. So it's a yes and a yes. So it's going to form H2S plus a salt. What salt? A front we haven't used and a back we haven't used, right? I haven't used SN and haven't used Br. This looks just like that because it tells me so. You do not need to put the states of matter in for the purposes of skill today. All right, now what charge is it? Okay, so we got to go back here because tin can be multiple oxidation states. It has a roommate. So SN's a +1, this looks like it, and SN is S is a -1. SN's a +1, S is a -1. Check the negative. This should not be a -1 if I look on my ion sheet. It should be a 2. So now I know this is a +2, and we already knew this was a -1 because remember we'd multiply this, and this is really this. Just when we write it, we crisscross reduce and got back to that, if you recall from our last week's set of notes. So that's going to do that. And then be sure you're balanced. It's your job to balance. Okay, so this is a compound only. So my option is the elements breaking down or it's on this list. If it's a compound only. Only choices I have if it's just a compound, is it one of these decomps or is it just the element breaking apart? It's not any of these. Looks close, but this isn't it. Because that's a cobalt, that's a carbon. So that means it's just cobalt and oxygen, those breaking apart. Cobalt is not diatomic. Oxygen is, so it gets an O2. Remember Brinkelhoff? Please back.